Hello dear students, today I am going to discuss Cambridge IGCSE Chemistry October-November 2023 Paper 41, Paper 4 Theory Extended. Let's move. Number 1. A list of gases is shown: ammonia, carbon dioxide, carbon monoxide, ethene, fluorine, oxygen, sulfur dioxide, xenon. All are gases. Answer the following questions using only the gases from the list. Each gas may be used once, more than once, or not at all. Give the name of the gas that cause acid rain, number A. And sulfur dioxide gas is responsible for acid rain. Sulfur dioxide convert to sulfur trioxide. Then sulfur trioxide reacts with water to produce sulfurous acid. Sulfurous acid oxidized by air to form sulfuric acid. Sulfuric acid is responsible for acid rain. So here gas sulfur dioxide causes for acid rain. B. Forms an alkaline solution when dissolved in water. And ammonia gas when dissolved in water to produce ammonium hydroxide. Ammonium hydroxide is an alkali solution because it produces hydroxide ion. So hydroxide ion solution is alkaline solution. Then number C is inert. Xenon gas is a noble gas. Noble gas are inert, they are unreactive. D is a product of photosynthesis. Photosynthesis product, plant use carbon dioxide and water in presence of sunlight to produce glucose and oxygen. So oxygen gas is the product of photosynthesis process. Number E, can form a polymer, ethene. And ethene molecule, many alkene molecule combine to form polyethene. Polyethene is an addition polymer. So this answer will be ethene. F is produced in the test tube for nitrate ion. Nitrate ion test, any nitrate compound, if you add sodium hydroxide and plus aluminum foil, if you give heat, ammonia gas produce. So test for nitrate ion, to a small amount of nitrate compound, sodium hydroxide and aluminum foil is added and gently warm. Ammonia gas is produced which turns damp red litmus paper to blue. So is produced in the test for nitrate ion. Nitrate ion test, ammonia gas is produced. Next, number 2, boron and aluminium are group 3 elements. Boron has only 2 natural occurring isotopes, boron 10 and boron 11, 2 isotopes. So complete the table to show the number of protons, neutrons and electrons in an atom of boron 11, B11. So here number of proton, and you know boron atomic number is 5. So number of proton equal to atomic number 5. Number of neutron 11 mass number minus proton number equals 6. And number of electrons will be 5. As boron 511 is a neutral atom, so for neutral atom number of proton equal number of electron, that's why 5. Next, B, the relative atomic mass of boron to 1 decimal place is 10.8. Number 1, determine the relative abundance of boron 10 present in boron. Gives your answer as a percentage. So boron 10, let percentage of boron 10 is X. So 11 will be 100 minus X. Now you see relative atomic mass is given 10.8. 10.8 equal mass times percentage of 10 plus mass times into percentage divided by 100. This is the formula. So AR equal mass into percentage plus another mass into percentage divided by 100. If you solve it, you will get X 20%. As you let X boron 10 is X, so question is asking calculate the relative abundance of boron 10, so it will be 20%. Then number 2, use the relative atomic mass of boron to calculate the number of atoms in 0.540 gram of boron. Mass is given. Give your answer in standard form. So at first, as mass is given, you will calculate mole of boron, mass divided by molar mass, means as boron is 1 atom, so 10.8 is the relative atomic mass. Mole equal mass in gram divided by relative atomic mass, so you will get 0.05 mole. Then formula, number of atoms equal number of mole times Avogadro constant so moles times Avogadro constant times number of atom. So as boron is a 1 atom, multiply by 1. So if you calculate, you get 3.01 10 to the power 23 number of atoms. You will get number of mole times Avogadro constant. You will get the answer. Next, number C, aluminum is extracted from its ore, purified ore, as shown in diagram. This is block, this is positive electrode, anode, and steel tank, negative electrode, this is cathode. Here molten aluminum. So you are asking Number 1, name the ore of aluminum. You know, aluminum ore name is bauxite. Bauxite, bauxite. Aluminum is extracted from its ore, bauxite. Number 2, the electrolyte contains aluminum oxide and one of other substance. Name the other substance and explain why it is used. Other substance name is cryolite, 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 and explanation why cryolite is used. It lowers the melting temperature, or you can write it lowers the operating temperature, starting temperature, and it lowers the melting temperature of the mixer, or you can write improves conductivity. Now number 3, write the ionic half equation for the reaction at the cathode. You know, at the cathode reduction reaction occur. So aluminum ion takes 3 electron to produce aluminum Al. At the cathode, aluminum ions gains 3 electron reduce to produce molten aluminum. Number 4, explain why the anodes need frequent replacement. Why the anode should be replaced time to time? This answer will be as at anode oxide ion are oxidized to produce oxygen gas, and you know, at anode oxide ion lose electron oxidize to produce oxygen. This oxygen reacts with carbon. Carbon anode is made of carbon. So as oxygen produce, oxygen reacts with anode to produce carbon dioxide. That's why anode is destroyed. That's why it needs to be replaced time to time. So answer will be carbon reacts with oxygen to produce carbon dioxide. Or you can write at the anode oxygen is produced, so oxygen reacts with anode, oxygen burns away anode to form carbon dioxide. D. State 2 physical properties of aluminum that make it suitable for use in overhead electrical cables. So number 1, good conductor of electricity. Aluminum is a good conductor of electricity, and also it has low density. Then next E, explain the apparent unreactivity of aluminum. And you know, aluminum oxide layer is formed which is unreactive. Aluminum reacts with oxygen to form a layer of Al2O3 aluminum oxide. This layer is very strong and unreactive. So explain the apparent unreactivity of aluminum. Aluminum reacts with oxygen to produce aluminum oxide layers is formed which is unreactive. And F, aluminum reacts with fluorine to form aluminum fluoride is an ionic compound. Write the symbol equation for this reaction. And this aluminum reacts with fluorine to form aluminum fluoride AlF3. Here aluminum valence is 3, aluminum valence is 3, fluoride valence is 1, so 1 no need to write, AlF3. So 3F2, 3 to the 6 fluorine, 3 to the 6, 2L, valence equation. Then number 2, complete figure 2.2 show the electronic configuration of one aluminum ion and one fluoride ion. And you see aluminum 3 plus, it has 10 electron. So first shell contains 2 electron, second shell contains 8 electron, 2, 4, 6, 8, and 3 plus means it lost 3 electron. And fluoride ion has 8 electrons, 10 electrons total. Fluorine has 9 electrons, F minus means 10 electrons. First shell 2, second shell 2, 4, 6, 7, so 1 gain, that's why it is F minus. So aluminum lose 3 electron to form Al3 plus, fluorine gain 1 electron to produce F minus. Next, number 3, order of reactivity can be determined by displacement reactions. A student investigates the reactivity of 4 metals by carrying out a series of experiments. Each of the metals lead, manganese, silver and zinc are added separately to aqueous metal nitrates of the other metals, metal nitrate. So table 1 shows the sum of this result. You see aqueous solution, metal, lead to nitrate is added to lead, manganese, silver, zinc is added to lead nitrate, manganese to nitrate, silver nitrate, zinc nitrate. So you see here zinc is more reactive, so zinc displaces lead. Here all tick mark reacts. Zinc will react, lead nitrate, manganese to nitrate, silver nitrate. Then so zinc is most reactive. Then you see lead reacts with silver nitrate. That means lead is reactive than silver. Now manganese reacts with lead to nitrate and silver nitrate. So manganese is more reactive than lead and silver. And silver metal, you see silver metal does not react with lead nitrate, manganese to nitrate, also zinc nitrate. So silver is the least reactive. Now Depending upon this result, complete the table and place the 4 metals in order of reactivity with the most reactive first. Zinc is the most reactive, then manganese, then lead, silver is the least reactive. This is the answer. And then number 2, suggest why the metal nitrates and not the metal sulfates of these 4 metals are used as the aqueous solution. And you know, all nitrates are soluble, but lead sulfate is insoluble. So you can write why metal nitrates are used, because all metal nitrates are soluble, but, or you can write lead sulfate is insoluble. Number 3, write the symbol equation for the reaction between zinc and silver nitrate. Zinc, silver nitrate, and you know, zinc is more reactive, so zinc displaces silver. Zinc nitrate and silver is formed. This is a displacement reaction. Why the reaction happen? Zinc is more reactive than silver, so zinc displaces silver from its salt. Next, B. The reactivity of group 7 elements can be investigated experimentally. A student bubbles chlorine gas into a test tube containing aqueous potassium bromide. So describe the color change seen in the test tube. From colorless to orange, chlorine gas into containing potassium bromide. So colorless to orange, because this reaction is this reaction. Chlorine displays bromide ion, so bromide ion aqueous solution, or potassium bromide KBr aqueous solution is colorless. If you chlorine gas pass through it, chlorine is more reactive than bromine, so KCl plus bromine aqueous solution will form. Displacement reaction occur. So observation will be KBr solution aqueous is colorless, bromine aqueous orange color. So colorless solution turns to orange. That's the answer. Then number 2, complete the ionic equation for this reaction. So include state symbols: chlorine gas, bromide ion aqueous, bromine aqueous, chloride ion aqueous. Then 3, the reactivity trend seen in chlorine, bromine and iodine applies to all elements in group 7. Use the periodic table to identify the group 7 element which cannot displace any other group 7 elements. And as you know, group 7 elements down the group, reactivity decreases. So tennessine is the least reactive metal, reactive non-metal. Tennessine is Tennessine is the below of the group 7, so it is least reactive non-metal, so it cannot displace any other non-metal. That's why it answer TS or Tennessine. You can write the answer. Thank you, dear students.